Welcome to The Explainer. So today, we're going to unmask the tech revolution that is, well, it's everywhere, artificial intelligence. We're going to go way beyond the hype and really get into how these systems actually think and, why that really matters for all of us. So let's get right into it.
I mean, you've seen it, right? AI can write poetry, create these mind-blowing images. It can even drive a car. It seriously feels like magic. But is it some kind of mysterious, unknowable force? Or is there something real going on that we can actually understand? Well, here's the spoiler. It's not magic. It's just math. Okay, so at its most basic level, an AI isn't some thinking robot out of a movie. Nope. It's actually what the experts call an agent. And you can just think of it like this. It's a simple loop. It senses the world around it, using data as its sensors, and then it acts on that world, using its outputs, or actuators. That's it. It's a really simple idea, but believe me, this simple loop is the building block for, well, everything we're about to talk about. All right, so we've got this simple loop of sensing and acting. That's our starting point. But how does an agent get smart? How does it go from just doing basic things to actually learning? Well, that is the real breakthrough. This is what changed everything. So for the longest time, programming was all about writing rules by hand. If a user clicks this, then show them that. But you hit a wall pretty fast. I mean, how could you possibly write enough rules to describe something as complicated as a cat or as subtle as a joke? You just can't. The huge shift with modern AI was this big realization. We don't have to. Instead of writing the rules, we started feeding the models massive, and I mean massive, amounts of data, and just let them figure out the patterns for themselves. And this, right here, this is the machine they use to find all those patterns. It's called a neural network, and it's kind of modeled after our own brains. So when you show it an image, like this ship, the first layer of this network, it might just see simple stuff, like lines and edges. But then the next layer combines those lines into more complex shapes, right? Like masts and hulls. And it keeps going, layer by layer, building up this understanding until, bam, at the very end, it's learned the complex pattern, like the unique fingerprint of what makes a ship, well, a ship. Okay, but what happens when the network messes up? I mean, when it gets it wrong? Well, that's where something called the loss function comes in. The best way to think about it is like a teacher's red pen. It's basically a score that measures exactly how wrong the model's guess was. If it's a huge mistake, it gets a big penalty. And that penalty, that's the key. That's the signal that guides the entire learning process. It tells the model, hey, that was wrong. Adjust your thinking and try again. And with every single attempt, it gets just a little bit smarter. So what happens when you take this learning process and you scale it up to an absolutely unbelievable level, like training a single model on a giant chunk of the entire internet? Well, you get something totally new and incredibly powerful: foundation models. Seriously, these are the engines driving pretty much every major AI app you're using today. See, the old way of doing AI was to train a model for just one single task, like playing chess. That's all it could do. But these new foundation models, they're generalists. Because they've learned from such a wild variety of data, one single model can translate languages, summarize a long report for you, and even write computer code, all without having to be retrained for each new job. It's a total game changer. So how does all this work with language? Well, models like ChatGPT, they're basically just incredibly sophisticated next word predictors. That's what's happening under the hood. Just like this quote gets at, they process text one piece at a time in a sequence, and they're constantly updating what they know to make the best possible guess for what word should come next. The best analogy I've heard, it's like autocomplete on a cosmic scale. Okay, but what about images? This is super cool. AI image models, they don't really paint like a human would. Instead, they start with a screen of just pure random noise, like old school TV static. And then the model, which has been trained to find patterns in all that noise, starts to reverse the process. It works step by step, slowly pulling a clear image out of all that chaos. It's really less like painting and a lot more like sculpting. Okay, so we've got these incredibly powerful general purpose models, and that is a huge, huge breakthrough. But the real magic, especially for businesses and, for all of us, is when you can take that generalist and turn it into a super focused specialist, something that's perfectly tuned for exactly what you need it to do. And this has completely flipped the script for the entire industry. I mean, it's not really about building a model from the ground up anymore. That's just wildly expensive. Now, for so many engineers, the job is all about adapting these giant pre-trained foundation models. And that means the interface, how we actually talk to the AI, has become unbelievably important. And this chart right here shows you just how critical that interface is. Seriously, take a look at the performance of Google's Gemini Ultra model here. With just a standard, simple prompt, it gets a score of about 84%. Not bad, but by using a smarter, more advanced prompting technique, that score jumps all the way up to over 90%. We're talking about going from a B to an A+ with the exact same model. The only thing that changed was the instructions we gave it. That is the power of a good prompt. And this has created a whole new skill, prompt engineering. It's really both an art and a science, all about crafting the perfect input to get exactly what you want out of the model. So instead of just saying, summarize this document, a good prompt engineer might say, okay, I want you to act like a senior business analyst. Now summarize this document into 3 key bullet points for a busy CEO, and make sure you focus on the financial implications. You see the difference? It's all about giving the AI the right context, the right persona, and you do all of this without ever touching the model's actual code. But sometimes just giving good instructions isn't enough. What if you need real deep expertise? Well, that's where something called fine-tuning comes into play. This is where you actually take that big generalist model and you continue its training, but this time on a much smaller, super specific set of data. The best analogy? It's like taking a general practice doctor and sending them to a specialized medical school so they can become a world-class brain surgeon. Same person, just with extra focused training. So, where does all of this lead? I mean, understanding how these powerful models work is one thing, but actually shaping the future with them? Well, that comes with some unbelievable opportunities, but also some really serious challenges that we absolutely have to talk about. Yeah, we really have to be honest about the hurdles here. First off, these models are just incredibly expensive to build and to run. Second, they can hallucinate, which is the term for when they generate information that sounds totally convincing but is completely made up. And third, and this is a big one, because they learn from all the messy data that we humans create, they can pick up and even amplify our worst biases. But even with all those challenges, the pace of progress is it's breathtaking. And a huge reason why, as this quote points out, is that this isn't just happening at one company. It's a worldwide community of researchers and engineers all sharing, competing, and building on top of each other's work with this incredible energy and creativity. You know, maybe the best way to think about AI isn't as some kind of artificial mind. Maybe it's more like a new utility, kind of like electricity. It's this powerful, general-purpose technology that we can use for a million different things. It's not inherently good or bad. So the real question isn't, what is AI going to do to us? The real question is, what are we going to do with it? So, how are you going to use it to build the future?